Hi everybody, this is the last video about the nanodevices, and in this video we are going to talk about the process in which the wounds are healed. Just imagine if you cut your skin with a knife and the blood comes out, you see that day by day your wound is going to be healed and finally it is closed. But what happens exactly? If you remember, in the section of the hydrogels we talked about the mechanical forces that the cells have to feel in order to survive, and we told you about the RGF, which is responsible for connecting the cells to each other so that they feel that they are connected to each other and they will survive. The same process happens here, but the difference is that when the wound is created, so when our skin is cut, the fibroblasts, they will migrate here and they will differentiate to the so-called myofibroblasts by the help of the growth factors that I can show you here. Just imagine we have the fibroblasts, and when they feel the mechanical tension, so they will first differentiate to the so-called proto-myofibroblast, and in the presence of the growth factors such as the TGF beta 1, they will differentiate to the final myofibroblasts, which are highly contractile, and they are responsible for applying the force in order to close the wound that we have here. But in order to have a quantitative study of how this happens, of how the forces are applied, the direction of them, the amount of force that these fibroblasts apply, this model has been presented, and it works based on the injection of the nanoparticles, which can be detected under the fluorescence microscopy. Just imagine if we injected the nanoparticles that can be recognized under the fluorescence microscopy into these fibroblast matrix before the forces are applied and after the forces are applied. We take some pictures and we see that when the forces are applied, the nanoparticles, for example here, are going to be formed in this way, because the forces applied to contract the tissue and the nanoparticles inside them has also been moved in this direction. So by measuring the amount of displacement of the particles, for example, from this part to this part, and knowing the modulus of the tissue that we have here. Do you remember the modulus that I told you? For example, if we have a material and we apply a force on this end and this end, we apply a stress, so it will deformate, it will elongate, depending on the amount of Young modulus when we were talking about the hydrogels, the Young model. So this is the same story here. If we know the modulus of the tissue and the displacement of the nanoparticles, we can measure the amount of stress that have been applied here, the amount of force that have been applied by the myofibroblasts, and also the direction. The direction can be obtained depending on the direction that the nanoparticles have been displaced. Well, it gives us the quantitative measurement of the myofibroblasts. So this is the end of the nanodevices video number 4, and these are the topics that to the best of my knowledge are not going to be included for the exam. So if you are interested, you can study on your own, and in the next videos we will cover the immune system of the body and the nanotoxicology.